That was too much for us.
Yes.
So first of all, Kaveh, come
Kaveh.
here. Explain yourself.
Explain yourself. What are you?
No, look at the camera.
What are you? Yes.
Yes.
Very good, thank you.
Thank you.
I mean, everybody knows them.
Yeah.
The weatherman.
Recap the weatherman. I'm a repeat guest on your.
Yeah,
Yes.
but you will never get repetitive or something like that.
Yes. I'll never get old.
Yeah. Okay.
Yeah.
Oh.
I mean, I would get physically old, but
Timeless.
it's timeless.
Okay. So tell us about the clouds. How is it? How are
I
they?
mean, the basics are this. You have moisture low, close to the ground. that
That's
heats
called
up.
fog.
Nope.
No. Okay.
No. Moisture is just in the air, like if humidity. There's water. There's
Oh,
wa-
okay. Like we don't
There's
see
water molecules that are in gas form, that are in the air. They're dissolved.
that. That's true. I know that.
Yeah. So when humidity goes up, sun hits the ground, heats up.
Mm-hmm.
Water evaporates. More humidity, but it's also hot air. So it's going up.
Okay.
So hot air goes up, eventually hits a point where the humidity, temperature, and pressure are such.
Humidity, temperature, and pressure. Okay.
It's basically air has.
PVNRT. Is that
Yeah,
equation?
that's the ideal gas law, but
Okay.
this is more about solubility. Where like the air has some capacity to hold water molecules in itself. Depending on the pressure, temperature, and humidity, the humidity is basically how much water is already in the air.
Yes.
There's
So
some-
it is
there's
pressure.
Pressure, temperature, both.
Oh, that's N. Alright, NRT.
Yeah, so no. This is not the ideal gas law. This is about how much water can be dissolved in the air.
Mhm.
Right, like
Uniformly.
if you have water, you can put sugar in it and it will get dissolved.
Yes,
It's
yes.
the same idea, but like water getting dissolved in air.
Okay, got it.
Right. So depending on the temperature and pressure, the amount of water that can be dissolved in the air.
So you are saying clouds are actually like this.
So when the
No, wait, I know. This sugar thing we have. Nabot, shall we know?
Yeah, more or less, yeah. But
What
like
do you
instead
call
of
Nabot so that our friends from all over the
yeah, the
Rock.
sugar crystals.
sugar crystals.
Yeah, it just when yes, if you slowly and in a controlled way, if you have what's called an oversaturated
Yes, oversaturated.
solution of something.
And then you cool it down.
Yes, and if that underlying molecule can form a crystal, it can crystallize into something.
But clouds are not crystal.
No, clouds are droplets. I know crystals happen when you have a solid, not a
Oh,
liquid.
yes.
Yeah.
Yes.
Anyways, the idea is there's a certain amount of moisture that the air can hold.
Mm-hmm.
Now you have moist, hot air at the surface
Yes.
because of the sun.
Yes.
Now this is hotter, so
Uh-huh.
natural convection means that it's going to go up.
Yes.
This is hotter than the surrounding air.
Yes.
It's going to go up, and then it creates a high pressure region,
Mm-hmm.
and then up, it flows up to the lower pressure region above. But it carries that moisture that was evaporated with it.
Yeah.
And at some point, the temperature and pressure get low enough, and the humidity at certain altitude
Mm-hmm.
is enough where the water can no longer be dissolved in the air.
Mm.
So it has to become a liquid because the temperature, naturally water would be a liquid, right?
So when we have fog, is it because the
Yeah,
weather
it's
becomes...
because the dew point is that temperature for the given conditions for the
So
kid.
what is dew point? Dew point is we don't have it. Let's put it on this one.
Yeah.
So we have like how many molecules do we need in?
In what?
All right, I want you.
It's
to
not about how many molecules.
Mm.
See, okay.
How many water molecules?
Yeah, so I wouldn't know how many, but it's about what's the
on,
concentration.
I told you come ready.
Come ready for what, dude?
All right, so I want you to draw it for us. Kaveh, what do you say?
I honestly don't know.
Can you
Like, I'm speechless.
predict what is going to happen with the clouds after this level?
Yeah.
All right. Oh, okay. I
It's
know.
gonna rain, I guess.
Well, rain happens when other conditions.
Yes. All right. I think you can. So how many, like this is a
Yeah.
what is it, 1 centimeter cubes
Mhm.
or whatever. And we have like water molecules, right?
Yes.
These are in it. And then when we go up, the pressure goes,
So you have a certain amount of
okay, go
humidity.
ahead, you
So
tell me
hu-
this story.
Okay, so humidity is it's defined as a relative measure of how much water there is in the air versus how much water it can hold. So the official definition of what humidity is, when you open up the weather app, it says humidity whatever percent.
Mm-hmm.
That is not just the number of molecules of water in the air.
Uh-huh.
That is
It's
a
the
relative.
ratio.
It's a relative to the conditions of the air. So like if you have high temperature, there's more capacity for water to be in the air. So
Yes.
humidity is going to be a relative measure.
Uh-huh. Okay.
So the percent, that's why it's a percentage, and it's not.
So it is like, this is low altitude, like, alright, when we
Alright,
go
the very
up.
simple, the very simple idea is you have, like, let's say this is the ground,
Uh-huh.
right? And then you have sunlight.
Mm-hmm.
This hits here,
Yes.
and the temperature goes up, right?
Yeah.
And then up here in the altitude, you have some T at, let's say, like 3,000 feet,
Yes.
which is smaller than this,
Mm-hmm.
right? So this air is going to be, this air is going to have a lower temperature. This is going to have a higher temperature. So natural convection is going to create a pressure difference.
Yes.
So this air is going to flow up.
Yes, this much I know. I just, what I'm curious about is
Right.
like,
Okay. Wait.
if we look at the cube here, cube
Yeah.
of like volume, on the ground, and as we go up, how many?
Right. So that's the
How
thing.
does
though,
it change?
Because the pressure drops too.
Uh-huh.
So the density of air goes down, so the molecules will be more dispersed. But
Um,
that's not the point.
okay.
The point is, given some temperature and some pressure,
Okay.
right, you're going to have a dew temperature.
So what
Well,
happens?
for
What
a given-
happens in the dew temperature in the
Yeah, so
molecular?
for a given pressure, let's say like P star,
Uh-huh.
you're going to have some dew temperature
Okay.
for the air.
Yeah.
This is the temperature that if the air at this pressure reaches,
Okay.
right, you're no longer going to be able to hold on to the amount of water you have. So you have a certain amount of water.
They connect with each other.
Right. You have a certain amount of water
Okay.
in this here.
Uh-huh.
If the temperature of this box and the pressure, a mixture of them, hits a certain point, your box of air is no longer able to hold on to water molecules.
I see.
Right?
Like
Yeah.
not at all, or
Not at all. Not even a single molecule can be added.
Is-
Why? Because as soon as you add that molecule, these molecules start coalescing into droplets.
Okay.
Right? Like at
Yeah,
that point,
makes
once you hit the dew point, which is like some pressure dew and
Is
some temperature
dew point the same, like just converting from gas to
No.
liquid, or it's
No.
a different thing?
No,
What
because
is that
water,
called? What is that called in
water.
English?
So there's a phase diagram that
Yes.
if
Yes.
any material has a phase diagram,
Yeah.
right? And the phase diagram is usually like, it's gonna have a triple point where like you
What
know,
do you call when vapor turns to liquid?
like condensation.
Condensation.
Yeah, yeah.
So condensation is different from dew.
Again, these are separate concepts.
Okay.
Condensation means you have a gaseous material that
Mhm.
turns into liquid.
Yes.
That's condensation.
Well, dew is also. Well,
The dew point is just a measure of how much water the air can hold on to without it becoming
it's
liquid.
also, it's just about where
Right,
it
so
comes from.
what you have with any fluid
Mhm.
is that these molecules are not super tightly bound.
Yeah. Okay.
Like
got
in
it.
solids, they usually form a crystal,
Mhm.
like in metals at least. You have a very specific crystal structure and they're held together.
Mhm.
It's not gonna evaporate. Like you don't put some steel here and the steel evaporates over time. But you put water here, eventually the water would evaporate,
Yes.
right? That's because they're like more loosely bound.
Yes.
The dew point basically determines, given this condition of air,
Mhm.
how much water can it hold? Like how many water molecules can you have before the solution becomes unstable?
Mhm.
Basically, as soon as now, once you hit the dew point, you add a water molecule, that's it. it's gonna coalesce into. It's
I
gonna
see.
condense. It's gonna create
I see.
So
droplets.
is it a measure of like how many molecules
It's
can
a-
we
it's a
have,
measure
or
of-
is it temperature?
No. It's temperature and pressure. The dew point is two things.
It depends on the like what is it, the liquid or the gas
so
that
dew
we are.
point is a function
Dew
of
point.
the temperature.
Give me humidity. Give me pressure. Give me temperature, and then I'll tell you what the dew point is.
Can
So
you
like
give
how
one
much
more time?
how much water you have also
Humidity.
matters.
Oh, I see. The starting point matters as well.
Yeah.
I see.
So humidity 10, pressure 20.
Well, I don't know the equation. I don't know the equation, but the idea being, if you hit the dew point,
Uh-huh.
now there's no longer a capacity to hold on
So
to water.
what I like to know is like when we are at the dew
Right.
point.
So this thing keeps
the-
going up. This thing keeps going up, and at some altitude,
Mhm.
it reaches the conditions
Mhm.
where the air no longer can hold on to the water it has, and what you start to see is droplets forming.
Droplets. Why don't they rain? Why don't?
Yeah, we'll get to
Why
that.
do they turn into?
Yeah, right.
clouds?
So that's easier to show. So think of this as a droplet.
Mhm.
It has a certain radius.
R. Okay.
Yeah. If this radius gets bigger than a certain amount, it becomes unstable, and the aerodynamic forces will no longer be able to hold on to this. So, like simple thing, right?
So
Water has a density of water
it's one.
is larger than density of air, right?
Exactly.
So without anything, this should just fall.
Yes.
Normally, it shouldn't float.
Mm.
However, as soon as this starts falling, there's a drag force that's going to act on it.
I see.
And because it's small enough,
Mhm.
this drag force is going to be very quickly high. Like for a very low velocity, the drag will be high.
Mhm.
And then you have like a upwards current, if you remember.
I see. All
Right?
of them add
Yeah, so
to
the upwards current is basically creating a flow like this, where there's drag, and then you have like the mass here.
I see.
And they balance out each other. It just floats.
Mm.
It just floats. And then the wind moves everything around.
So okay.
But there's this upward, if this upwards flow wasn't there, then the cloud wouldn't have formed in the first place. Like the
Mhm.
idea is the cloud forms because there's an upwards flow.
I see.
Now, if the clouds get dense enough, as in there's so many droplets in the cloud,
Mm-hmm.
that they start to coalesce.
Mhm.
Like droplets start hitting each other a lot.
Mm-hmm.
Because when the droplets hit each other, they get big.
Yes.
And if there's too many droplets, the cloud is super dense,
Yes.
the droplets start hitting each other, and then they get past the point of, let's call it RC, like a critical radius,
Okay.
where the aerodynamic forces are no longer enough, they're gonna get too big and they're just gonna drop, like
I see.
just rain.
Okay.
That's
All
it.
right. So okay, but this is like one droplet. What
Yeah.
I am
So what
curious
this is,
about
the
like
reason you see white color and all this is because it's an
white
air-
color.
Yeah, the clouds are white.
Yes.
Or like you see them as
Oh,
white.
that's also interesting. What
Yeah,
are
that's
they?
refraction. That's just so like when you have many of these droplets.
That's actually a great one. Why are the clouds white?
I mean, sometimes they're gray, like when it's
Yeah,
dark
like
and
now
gray,
it's
it
gray,
turns
but I
gray.
think-
Yeah,
it's
yeah.
because of
But,
the-
well, that's just it doesn't matter. The reason it's not just colorless
Mm.
Yeah.
is because these droplets they divert light
Yeah.
as the light hits them.
Mm-hmm.
So the light doesn't go through directly. Some of it gets reflected. Some of it goes through at a different angle,
Mm-hmm.
and it also there's a lens effect as well, where you sometimes you see, for example, if the droplets don't form a cloud but they exist in the air, like right after rain,
Then you see the rain.
you see a rainbow.
Oh, like prism, basically what it's called. That breaks-
Prism, yeah. I mean, a prism will break, but it's not a prism. Like it's
Alright.
it's a bunch of droplets, and so basically it's just light interacting with the
Yes.
droplets, and you have many of them. So this is basically what's called this is like an aerosol, but aerosol also can be spray, so they're not really like you don't see color, but it's like a spray.
I see.
This is a form of water, or like this kind of like when you have a liquid like this as a spray aerosol or just normal water, it's called atomized. They call it atomized. It's a
But
spray
they are
term, like
bigger
it's a spray
than
theory
atoms,
terms. Yeah,
right?
yeah, yeah.
They're bigger.
They're
than-
huge. It's just a term they use. It's
Mhm.
atomized.
So
Yeah.
How
so
do these-
so you can create these by force, right? You can create a cloud by force without dew point, without any of this.
what consensual? All right.
Yeah, the way you can force an aerosol to exist is a spray.
Okay.
Well, basically,
How do they make like
Yeah, that's just the nozzle.
nozzle? So what does nozzle do that makes it?
Well, I don't know. Okay, the simplest form of spray.
You can search the internet too.
I have some videos
Wi-Fi.
of this stuff. So I in my undergrad I did a bunch of experiments. If we could get into my Google Drive, I can show you
Squirting.
videos of things happening. Yeah.
Thank you. Alright, so I have a question.
Yeah.
Alright.
What if you fix the humidity and the pressure and just raise the temperature? Or
You
like
just-
no.
increase the temperature to
Yeah,
the dew
yeah, yeah.
point.
You'll give it that. Yeah, you'll just get condensation.
So
Alright.
like,
You know how
immediately it's gonna release all the water that it has.
Not all of it. It has some capacity for water.
Yeah.
Anything outside of that.
No, that's my point. Like if we change the temperature to
Hey.
the dew point.
Have you ever seen an air conditioner working outside?
Just like-
There's water coming out of it.
Yeah.
Yeah, that's exactly what happens. You got to remove the water
So
to,
it's
to
gonna
bring
be
the temperature down.
I
Otherwise,
see.
like there's no other way. Like to bring the temperature down, you got to remove the water from the air. So you just like naturally the water just is going to condensate. There's a condensator inside.
Oh, by the way, what about the dude? When you go like go to Mariel, like all these
Mario, yes.
swords or swish or what is it called on the ground there, like wells that steam comes out of them.
Yeah, so that's what I was getting to. Is like how do you force an aerosol?
Or
Aerosol.
yes.
Yeah.
Alright, go ahead. Go
With a
ahead.
spray.
But
do-
they don't have a spray.
Yeah, they have an ultrasonic atomizer.
Okay.
Yeah, it's a piezoelectric crystal that
Magnesium permanganate.
It could be any piezoelectric material. But the idea is with the piezoelectric material, you give it electricity, it's going to deform. Right, but it's going to deform at an ultrasonic frequency. I also have some videos of.
Alright, show them.
They're not videos, but like they're experiments, so like you can see it happening.
What about dry cleaners?
With
They
the,
have-
this is like one way to form a spray is by liquid sheets. When you have two jets of liquid coming in together, you see how the spray forms. When the two hit each other, you have to pull up my.
No,
But like this is
just
an
pull it,
aerosol
just-
in like a microscopic camera. This is the aerosol.
Yeah.
Like the droplets are just like moving around.
So many
So
jokes
when
came
we
to my
have,
mind
like-
when you showed the first one.
Yeah. I mean, I have a bunch of these experiments from back in undergrad. Oh, this is another form of spray, where you can shoot air into a liquid. These are just images, but like, you can blow up this single drop
Mhm.
into a spray, where you just like kind of aerosolizes.
Okay, that's actually very beautiful. Let me show that to them.
Alright, we can pull up my Google Drive here, and you can.
You can?
Yeah, I can just log in,
Alright. Do you want to do that?
or I can share this folder with you.
I don't want to pull up my Google Drive.
Yeah, maybe not do it as well. Like, just show it to the.
Yeah, just show them. Or yeah, I think he
So
has
this
to
is an
pull-
ultrasonic. So this is a piezoelectric atomizer.
What does piezoelectric mean?
So piezoelectric is a material where you induce a voltage. It changes.
It's resistant.
No. Okay. No. It's when you induce a voltage, it causes.
What was
strength.
your background? One more time.
Chemical engineering.
Yeah.
Chemical. Okay, so you should know.
I don't even remember. Okay. All right. Can you then log in? Can you log in?
Oh wow, a lot of no. Yeah,
What was the one that?
Just open up a incognito tab and I can log into that.
Oh, okay.
Kenma what?
Don't get into details, bro. It's your first podcast here. By the way, I didn't do that. Show it to the people.
You didn't?
I didn't.
Yeah, this happened in the wrestling
I have
practice.
forgot something. Is it
It's
this
okay,
one?
it's okay.
Okay, I don't want to share my username.
Yeah, don't share.
But you did.
I mean, almost,
Like
not
here.
all the way.
That's
But
what I was-
Just
is
stop
is
sharing
there,
and
no,
doing.
is there a way to switch the screen so that it's just us?
Yeah.
Yeah, just do that. Alright, you don't see my everything.
Guys, don't see. Even if you
You,
saw
you're gonna get so many,
emails.
scams.
I mean, it has like two-factor authentication. It's
No,
not-
but like
Oh, wait,
scammers-
this is a burner account, so I get all my scam emails here.
Good.
And also, like, I don't really give a shit.
You can check that. I mean, doesn't give a shit at all. I mean, like, you can
I
see.
don't even care, man.
Yeah, exactly. I don't care. Let's see.
Which
Coinbase wallet backups. That's a good place to go.
The mom's wheel.
Let's
So you
see.
said you had like 10 bitcoins or something?
I don't have any more. It's empty. Like they can go and pull up these wallets. They're empty. There's a droplet. This is one of them.
Alright, now you can.
These are the. This is like a simple.
This was nice.
This
Show
is a
them.
liquid sheet.
Can I share?
Yeah, this is a liquid sheet. Like two jets of liquid hitting each other creates a sheet, and then that sheet breaks into a spray. Like that's one way to make a spray. You can usually do this.
So we can do it with
You know-
hose too?
Yeah,
So
exactly. with the
is
hose.
that also a spray when
That's a
we
spray.
put our thumb in?
Yes, that's a spray because you create an aerosol. Like you create a spray.
Spray means creating an aerosol.
Yeah.
I feel like I've seen this thing.
And what about its shape?
Yeah.
What about its shape?
The sheet.
Yeah, why is it like this?
Why it forms a sheet?
Like geometrically,
tension?
what geometrically?
Oh, right. So there's no known shape exactly. Depending on the pressure and the velocity of the jets, it
Mhm.
changes what that looks like.
Mhm.
But what if it's exactly equal? And like 90
Right.
90
It
degrees?
depends on the Reynolds numbers of the jets. Like if they're really fast and they hit each other, it quickly just breaks down immediately. It doesn't form a sheet at all. It just creates a spray immediately. But if they're slow enough and they're laminar, then you get this like clean.
Laminar. What is laminar?
Laminar flow is like but not turbulent. But you see, like for a moment, it creates this clean sheet.
Yeah.
Just for a moment, where like the
Then
conditions are
something-
right, it's laminar, and then it stabilizes into like an elliptical shape.
Mm.
Well, hyperbolic
Layers
actually, not
of
elliptical,
sheet.
but it's a hyperbolic function if you.
It's interesting that it goes the other way as well.
Yeah, that one depends on the relative velocities. Like if one of them has more, then it's going to face more that way. So it's basically like imagine a hyperbola, just kind of like shifts in the principal axis of the hyperbola changes.
Nice.
Yeah, that was it.
Yeah, but anyways, like I mean, the other way to create a spray is like this, where you have a droplet and you blow air, like very high
Alright, show
pressure
that
air.
one too.
This may be a bad example here.
So one thing I'm very curious about is like the shape of clouds. Why do they look like the way they look like?
Oh, so that word is like not really something I know much about.
Alright, you can.
As far as the shape, but like why it just looks random mostly.
Yeah, why do they look so random?
Yeah, because like the flow is turbulent.
Alright, what are all the sources of randomness in
But I
it?
mean,
Wind, the pressure, the velocity of that. So like if you have a very fast moving, like you have a low pressure region up there
Mhm.
because of weather patterns.
So when you say
this
like
thing's
they
gonna
go
suck
up,
air so fast.
like
and
if
that,
we are
that
there,
cloud is just gonna like it's
So
gonna
you're
blow
saying-
over. Like you see that
So-
shape of like things. Just
no,
blow
you're
over.
saying if we are there and we put our head like downward,
Like
it
you've
will
been
be
in
like,
fog,
yes.
it just feels wet.
It
That's
feels
what a
bad, but
cloud
like
feels
the like the pressure, like the current,
yeah, you felt wind.
it feels like a wind.
Yeah.
Like when you're at a cloud, it feels like a wind.
Well, it
That
depends. Like,
going
in
up.
that moment, may not have that much upwards.
But if when there is upward, it is like
you
a
would
wind.
feel just it's airflow.
So it's like being in a parachute, like
Well,
floating.
not as much
not
as
as
that.
much.
It's like just
I
kind of
see.
like a wind.
Okay.
Yeah. Yeah. Anyways, I think I mean the idea is like one of the ways to make sprays like this, where you just blow really.
But clouds are not spray.
Clouds
Well,
are
how are
aerosol. They are.
Oh, they are arrows.
They're atomized particles or like atomized droplets of water.
Mhm.
That's what they are.
Aerosol. So the way they were
It's like
related to
aerosolized.
the aerosolized. All right, but not from a spray method. It's from doing.
Let's see, droplets. No, that's definitely something. So I have a whole. Oh, this is another one. Just
Show us one of these two.
well, these are not videos. They're just
Oh, the photos.
yeah. It's timed photos. It's like specifically timed at a certain moment.
They're all the same.
It's like time lapse photography, but like millisecond time lapse photography. So I have ones of microscopes. Where I did some experiments with microscopes. I don't know if these are. I don't know if I have them on my drive. I have a whole hard drive, like 2 terabytes of this data. Let's see, maybe here. Oh yeah, this is gonna be a lot of images. It's gonna be never ending. I mean, most of it is empty.
Show us one of them.
Yeah, I mean, most of these are gonna be empty because it's just the microscope just capturing. I mean, you can see some droplets in these, but not many, and they're very tiny.
Okay. So okay, all right. I forget what. So we have these droplets that turn into water droplets because of the dew.
Just because at some point, yeah, at some point it hits the dew point, and
So I want to know. We have these dew points. All right, all of these waters are dew points. Like this circle, this circle, this circle.
yeah, like here you can see like there's
By the way,
there's a stream of these like particles going through the microscope. Like for some moments you capture something.
I see.
Again, these are like test runs I think that I have on my drive. I have the full.
And we don't have any formula for their trajectory.
Yeah, so that's the funny part with sprays is mostly empirical things, and the main thing people care about with sprays usually is the size of the droplets or like the distribution of droplet size.
Oh, so how is their distribution? All right, if you don't
It's a
have
normal
the trajectory,
distribution typically.
it's normal. All
I
right.
mean, depends on how you make the aerosol.
Mhm.
If you make it with a spray that's very controlled nozzle,
Mm,
then yeah, they're going to be a normal distribution.
I see.
But in clouds,
Mhm.
I'm not sure. I have to look it up. Like I don't know.
So
I imagine it still will
what
be
I
somewhat
was.
of a
All right,
normal
all right, all
distribution.
right. Let me leave this. Do we need it
Like
anymore?
just one second, I wanted to see if I have some good photos of the
The thing was-
ultrasonic atomizer that you were talking
See,
about.
The thing was that I was looking on how to simulate shape of the clouds, and
Oh, it's gonna be hard.
ChatGPT like wrote the code, didn't do it itself.
Well, you can procedurally generate clouds like you do in video games, but those are not physically
Yes.
accurate clouds. They just look. Like
They look
clouds.
like, but they look very similar,
Yeah.
and they do it like it through a recursive method.
Yeah, imagine. Yeah, it means I don't know what exactly would that entails, but yeah. It just I'm not familiar. This is mostly a random process though. Like this is a.
Yeah, what kind of random processor?
I don't think it's
Well studied.
I don't think that the process is. Let me switch to. What's this one? Yeah. I don't think the process is chaotic. I mean, it is chaotic.
What do you mean by chaotic?
Like it's stochastic.
Okay, stochastic. Alright.
Yeah. But I don't think that the process is like fully like as in like I mean I guess like it is not chaotic. It is stochastic.
By the way, are they water or they are like ice?
It could be ice too. In
It
the
could
clouds,
be
yeah. In the clouds, it could be both. It's a
Mhm.
mixture of both. It's ice and.
Mm-hmm.
Um,
And how are they connected to each other? Or is
they
that-
are not connected.
They are not
If they
connected.
start connecting, then it rains.
I see.
Yeah, if they connect to each other, then it rains
That's true.
or
So
snows.
they are just like droplets or
Yeah.
ice pieces next to each other.
Yeah, they're
Close.
just floating. Yeah, sometimes they hit each other and get
I see.
bigger, but then when they start going down, they break up again. But
I
then
see.
there's not enough of them to coalesce so that it's big
Mm.
enough. Yeah.
What happens when we see a thunder?
What?
Thunder.
Oh, that's just voltage create. I don't know. I think
Isn't
the
it
clouds,
then two-
clouds
two
moving.
clouds,
Yeah, it's just
hitting
a
each
charge.
other?
Yeah, I think it's just a charge. There's a difference, a potential difference. I don't know. I don't think that's. I think the droplets moving in air maybe do that.
Yeah. Mostly.
Yeah, so like I think the droplets just moving in air,
Is
they
that?
create a charge.
It's not a must to rain, but many times when it rains, you see
Yeah,
like some form of like
Yeah, I think this is a separate phenomenon that I'm not familiar. I imagine it's like static charges when you make it with the clothes or whatever, like things rubbing against each other kind of make a charge.
Yeah.
The electrons start. I think that
So,
happens.
Kawa, what do you do at MIT? Alright, I think, is there anything special about clouds you want to say?
I mean, if you have any
For
questions.
me, it's always their shape that is interesting.
Yeah, I
And
think that's
fluffy.
I think that's a stochastic process.
stochastic process.
Maybe chaotic. I don't know.
Well, stochastic means chaotic.
No, chaotic
Yeah.
means even like there's no pattern to it. Chaos
I
is
mean-
chaos.
I mean, like there is nothing about its distribution.
Yeah,
I
exactly.
see.
Yeah. Stochastic means you know something about the underlying distribution.
I
We
see.
don't. I don't.
Like
I don't know if it's
it's
chaotic.
mean, mu, and
Yeah.
variance
I don't know if
equals
it's
square
stochastic or it's chaotic. I'm not sure.
root.
If it is chaotic, then it would be a little bit
Interesting. What is it?
because turbulence is like if you observe it statistically, it is stochastic. I think like turbulence. But there's like turbulence averaging models, so you can kind of like average out something. But yeah, it's unpredictable. I guess like meaning I think the idea being like it's not stochastic.
So if something is chaotic, we have no mathematics behind it, or there is some mathematics.
Well, I mean, maybe you can have some like pure random noise generation mathematics behind it, but I don't think it's predictable.
Yeah.
Like as in like the
That's
path it
really
takes. I think the path it takes is going to be purely.
Just ask for the difference between chaotic and a stochastic system. I think that would be a better question.
You just don't
you
talk
do
it.
Don't talk. Just do.
What is the string? Is it the one that tells you how much?
Yeah, it's a smart thing. I'm not used to this keyboard.
By the way, I think the stream is on us. If you wanted people to see that, they would.
No, I think it's recording.
No, it is recording, but it's,
It is,
you gotta switch in OBS to the scene to be.
That's my head is gone now. Yeah, that's
yeah. There you
Okay, yeah, I think. Okay, now it's caps lock, but
dude.
go. Yeah, ChatGPT knows.
Great question.
Great question.
I love. Alright, somebody read great questions.
I mean, stock market is like. So
Yeah.
Brownian motion is a stochastic.
Wait,
yes,
I'm
Brownian
here.
motion is stochastic.
But it says, oh, it says stochastic. Oh, I
Yeah,
thought
yeah,
it said
stochastic.
chaotic.
What was the difference? Alright.
Precise rules.
Oh, they are
where small changes in the
deterministic.
starting point lead to dramatically different
Extremely
outcomes.
sensitive thing.
Oh, I think that's the difference. So
okay, I think it's
if
not
you
right.
perturb the initial
Yeah,
code
yeah, yeah,
by
but
a little bit, then
Right.
the output would be very different.
Yeah.
But if it's a stochastic, if it's a like I don't know,
Yeah,
Monte
it's
Carlo or
like the
something.
randomness.
Yeah, there's some distribution associated with it.
Yeah, but the thing is
but
how,
it's
how to
random.
nail that down. Like I know, like
Yeah, so the
what's the
stochastic means it's random.
Mm-hmm.
However, like there's a distribution of outcomes. Chaotic means it's not random. There is some physics laws
Oh,
behind it.
weather
All right, so
system,
this
weather system.
I
Yeah,
think,
weather systems. There you go. Yeah,
I think this is the like probably like the closest that we can get to
unpredictability. Yeah.
the exponential sensitivity to the
So
initial conditions.
So the initial
What
conditions.
does exponential
So
sensitivity mean?
sensitivity is the output that you get if you perturb the input. Like,
Yes. Okay.
So that like it's an exponential function of the input.
Yeah, but like, so that's the thing. So there is a physics law behind it. It's deterministic in that
Mhm.
sense.
I see.
But just at an epsilon
So
change
I
in the
think
initial
clouds
condition.
are if clouds are
Well, I think it mentions the weather systems are.
Alright, that's
I mean,
chaotic.
weather system is a very vague term.
I would imagine because there should be some physics law behind what
Yeah.
the shape is.
Yeah, like so many moving parts, I guess. Yeah.
Yeah.
Honestly, like as soon as like we have like
A
couple of moving parts, I think we
but
can-
Yeah, so there's a
Wow,
deterministic
this is
difficult
it.
laws. Yeah, so yeah, they are chaotic. I mean, I would imagine they
oh,
would.
Navier
be.
Stokes.
at least
Well,
not
I don't think it's just Navier-Stokes. I think there's also like the molecular dynamics.
I mean, next podcast you should ask Amin to solve Navier
Yeah,
Stokes
they
for
should.
No, you can't solve Navier-Stokes. If you could, it's a
You. No,
millennial.
you can. You know,
Yeah, it's a,
You are
it's a
always
millennial problem.
believe in
Yeah, I
yourself.
believe you
$1
can.
million prize for it if you can.
You
$1 million is nothing.
You know
combining
about the
GPT.
millennial problems? Do you know
Yes,
what they are? Yeah,
yes.
that's one of them. Go ahead, do it.
We do it, dude. They put those names so that we do it, not to stay away from them, right?
But yeah, anyways, like the shapes are just gonna be random mostly. I mean, you can't really know.
They are not random. They are chaotic.
They're chaotic. Meaning that the initial conditions are what determine, and the initial conditions are more or less random. I think the initial conditions can be maybe modeled stochastically.
Fully dynamic.
The initial conditions being temperature, humidity, and so on. Right? This should be a
Honestly,
distribution
I
of
even-
what the average surface temperature of the Earth is 14 degrees Celsius. You know that. Right? So that being that that's the average, there's a distribution of surface temperatures.
Yeah, maybe like the temperature. You
So
can
like
model.
you can sample initial conditions, but they're gonna get wildly different results.
I see, yeah.
Yeah, either way, it's like you're not gonna predict this.
Are the clouds stochastic too? Yes and no. No, in theory, the underlying physics is deterministic. Yes.
Because we can
Yeah.
measure. I think this basically said what I said,
I
right?
see.
I said what I said.
Yeah, but anyways, like, it doesn't really matter. At the end of the day, the point being, you can't really know.
All right.
You can't predict
Oh,
it.
ask again. What is the shape of a? So wait a second, I don't get one thing. Okay, it is chaotic initial condition. What is the initial condition for a sea?
The humidity at the surface, what velocity of,
Okay.
what's your flow conditions, what are the
So-
Or even the
pressures?
wind, like.
Yeah, exactly. The wind determines.
Alright,
if
let's,
you have low
let's
pressure,
kill the wind for now.
low pressure. No, but that's exactly what matters. Like you have low pressure regions, high pressure regions. You get flows, you get jet streams.
Okay, then let's abstract
There's so
it.
much. There's so much that goes on in that. Like the airflow
Mm.
changes everything. The airflow is also chaotic, I think. And then that's just gonna. Yeah, you keep adding to the chaos.
Oh, you said it is, even we cannot simulate it mathematically.
You can simulate a small system.
I mean, if you have everything perfectly and you have infinite compute
Well, I mean,
power, you
when
can
you-
deterministically calculate the output. But
Yeah,
the
when you,
thing
when you
is-
have the simulation, you have to set some initial condition.
Yes.
And depending on that initial condition, you get wildly different outcome. So what is that initial
I
condition?
mean, Lorentz system is too complicated to be abstract, but yeah, this is a classic problem in control theory. Yeah,
What is Lorentz system?
it's
You
a
go
classic
ahead.
problem. Like, I don't know much. I know one of my friends is working on it, but this is like kind of the one of the first mathematical chaotic systems that people came up with in control theory, and yeah, like again, like
Oh, it has X, Y. Alright.
yeah, like if you
Yeah, this seems
look
like
at
a
the
nonlinear differential equation,
Yeah,
right?
it's-
So it's probably going to be kind of sensitive to initial condition.
But tell ChatGPT to plot Lorentz.
no, the Wikipedia page has.
Yeah.
So this is how the system looks like. So see the point here, it goes here, and then based
So I
on
guess
the,
like, depending on where you start, this whole path changes
Yeah.
entirely. If you just change your initial condition slightly,
Mm.
what if the
But
the
these
path will
paths are
change?
close also, aren't? Actually, I was.
no, this system is chaotic.
If
I
like,
think
you
it's
change your
chaotic.
initial condition, then this whole thing changes.
Let me show you this one. Are these one of these? Are they similar or no?
Anyways, I mean, the point being, like with these chaotic systems, there's some underlying physics laws, but you know. Just
Like, are these also like?
No, that's not chaotic.
This is not chaotic.
No, what do you
It's
mean?
deterministic as hell. What do you mean?
Well, chaotic is deterministic too.
No, this is like
No, but this is a known
sign
path.
of X applied on top of the
Yeah.
initial shape.
Well,
yeah.
these paths are known too.
Yeah, but it doesn't matter where you start there. You always end up with the same pattern.
I mean, it depends on the initial angle, but like, yeah.
What is this that we are seeing right now? What is
That's
it? Is
the
it?
that's the motion. of
So
the
this
motion of
is
the particle.
ZY plane, so it's X ZY, but this is like two of them,
Yeah.
and this.
Is it a closed loop? It goes back.
Yeah. But
The solution to this differential equation.
yeah,
That's what you
exactly.
see.
And you see it in two places.
So this is not
like
just
in the-
one path. It is all the paths.
Yeah, it just
Yeah,
goes
it's-
around.
It keeps going.
Now, if we change the initial condition,
Yeah,
what
change,
will happen?
Change the rho, sigma, and beta. and
No,
this
those
whole
are
thing
the
changes.
parameters. Those are not the. When
Or
we
I guess
say
yeah. I mean, change the initial condition, and this whole shape changes.
do it.
I don't know.
I don't know.
Do it-
How can we do that?
Do it yourself, DIY.
Yeah,
No,
just
I
write the
wanna
code
do
to do it.
Well, ask
Solve it
Chat-
numerically.
ask ChatGPT to do it.
Oh,
Let's see
just
what
change
happens.
from 4.0, at least code like use.
For oh, it does the job, I guess.
Does it code and simulate for you?
Can you
Yeah, make
tell it
a
to simulate itself?
Simple
Gemini.
No JavaScript. Tell him he does it itself
in
here.
Canvas. Yeah. Just give me a second, dude. Let's do. Simulate. Whereas,
I need to leave in a bit.
Dimensional conditions. I think it made the code, but it didn't render because you need to add the canvas thing in here.
Writer code maybe?
Yeah, canvas.
The keyboard is just like a little bit.
So what about fractals? Do they play a role here or no?
I don't think
Bro,
so.
I think fractals are pretty
Mm-hmm.
deterministic, right? Like the
Shit,
shape
the
is exactly.
fractal is
yes.
just like it's
Yeah.
repetitive, but it's
There's no initial condition there. Let's preview this. Let's see if this did anything. Oh yeah,
that's
it actually did
fantastic.
it. Yeah.
All right.
oh nice. Wikipedia should use this one. But like,
This
why
looks
is
really
it?
nice.
Yeah,
Wait,
it's-
do they see what we are seeing?
Yeah, I think so. I think they're seeing it.
Yeah. Okay. So wait, why is this top cut?
Yeah, so I think if we stop this and then run it again, it will use a different initial condition.
Well, give
Oh no,
us.
the initial condition
Alright,
are here.
let's
Slight
set it.
perturbation.
Yeah, just like
Oh,
code.
no, one is red, one is blue. Alright, A is, I guess, yeah.
Yeah, those
Oh,
are two
okay.
different. Yeah. I guess it's like trying to show like the blue goes in that direction, the red is.
Oh, okay, now.
Yeah, so
So
the
now the
dimension higher.
difference is
Like the
see
blue is
bond?
here, the red is there. It's a whole different thing now happens.
Yeah, they become kind of independent of each other. It's not like
This is crazy. I cannot follow up with the blue anymore, actually. Where is blue?
Yeah, but now it's too busy. But it was
Blue
like
was
right there
like-
for a second. Yeah.
I think.
Yeah. Anyways, the idea is they can clear, right?
But they're very close.
No,
I mean the
They're-
path
it's
is
there-
go in time. Like at any given time step, they are.
Yeah, at
very
any
different places.
different
I
times
mean, that's
that
the
they are
point,
very
but that's
different.
the point,
but
that's
the
what you're
general
solving
path, yeah.
Wow, look at this. The thing is that their what is it called? Their range, the set of all the paths they take is the same, kind of similar, very close.
Yeah. I guess like the pattern is similar,
Mm.
but at any given time step where they are, if you're trying to predict where this particle moving
Yeah.
with this equation of motion is,
No, yeah.
if you perturb the initial condition a little bit, it's going to be entirely different.
Yes.
Yeah, but in clouds, I guess it's a little different because now you have like three-dimensional geometry.
As what is the
turbulence,
length
so-
of this curve?
Length?
Length?
It's infinity. If you just go to infinite time.
It doesn't.
No, it doesn't
get
loop.
close in a
No.
loop. No. Okay.
No, it's not a close.
Because
loop.
it
goes-
get, like this radius is getting
Yeah, I don't think it's-
small and then suddenly it gets big and
Yeah, I don't think the path has a loop.
no, it doesn't have
ask
a loop.
it. Ask.
I think in general it does not have a loop.
This is crazy. Let's change the initial point a bit more. Let's see what that
Like what? I mean, it's already doing two.
Ah, this is just one. Okay.
Yeah, it's
Yeah,
one
that's-
thousandth.
No, the solution is not a closed curve.
What is it? A closed curve means the trajectory which is.
Yeah,
Yeah, it doesn't return to its
What
start.
is what it is? It's
I mean,
it's
I think for a system to be
it's a
chaotic,
strange
you kind of,
attractor.
I want to say you kind of have to have that condition. Like if it
What?
just goes back to the initial condition, it's
No, I think even like any given time step, if it's at a random.
so.
like if you have a 1D equation.
No. So hear me out. So if you start from here and you do this loop, if you move on that curve just a little bit, then you're gonna do the same loop again, right?
What I'm saying is you can have an equation of motion that moves along the same path,
Mm.
but the velocity is fully chaotic.
I see.
So at any time step, you could be anywhere.
Oh yeah, you're.
Yeah.
So it's not.
I don't think.
Oh, see, fuck you guys. Fractal. Over the time, the trajectory fills a fractal-shaped region of space. So it's the dimensionality of it is less than the dimension of the space it is in it.
Yeah, I mean, so I don't know. If you look at the underlying equation for a second, I think that can help a little bit.
How can it help? So what is okay? Right. Let me check. It is in the region of space that what makes it chaotic. Oh, so a chaotic system should become a fractal.
Not necessarily. I don't think so.
Like fluids don't make any fractals; they're fully
So,
just chaos.
And also, this is GPT-4o,
Yeah,
so if you don't
it's
like
probably
fully
bullshitting.
like fractal shape,
Because
is more
we
like
didn't read
a.
anything about fractal.
Yeah, I know, but it says.
Looks like a butterfly with looping wings. Alright.
Oh yeah, very
Particular
very.
never repeating, making it
What
three
is
different rooms.
the
Fractals are known things. Like,
I mean, fractal. The abstract
Fully defined.
definition is that the thing that repeats itself.
Exactly,
Like, you know,
it's fully defined.
Yeah.
It's
So what?
infinitely
Well,
defined.
chaos-
Chaotics
definition.
are also fully defined. What do you mean? They are fully defined too.
Their solution is yes, fully defined.
So what is this?
But like that's the point. The sensitivity to initial condition is what I'm making. Fractal is it's a static.
It doesn't say it says the shape of the curve is a fractal.
I don't know about whatever that means, but yeah, sure. I
Maybe
guess.
what it means is that if you repeat it for 1,000 times steps instead of like 100 times steps, the shape would
Maybe,
be
yeah.
like repeat
No.
10.
No, fractals. Okay, yeah, by
Just you
repeating.
can say what? You say, does the solution live on a known manifold? If that's the case, well, then you kind of know it's lower dimensional, which I imagine it would.
It is about the dimension of the space. It's not
Yeah,
about
yeah.
by repeating structures you can build lower.
Approximately
2.06 to 2.1.
Yeah.
I don't know what that means here. Like, honestly, this is not
I
making
know
sense to
what
me
it
anymore.
I know what it means.
You know what it means?
You know
Yes.
what it means to be a estimated
2.1.
2.06 to 2.1?
Yes, like they start covering the space with these balls that like curve with the balls, and then they see what is the minimum dimension. Okay, and then they
What?
do a summation. There is a dimension, a definition for
Okay,
Hausdorff.
what I know is like
No, Hausdorff's definition.
I don't
Hausdorff
know what
dimension
that
has
is.
has a definition, right? What is it? It's like you cover that space with balls, all right,
okay,
and then you sum all these balls.
the
Then
number of them.
uh,
Count.
no, their volume or their diagonal to the power of n, something like that, or to the power of d, and then you find the d that is the minimum d that this summation is something finite. Then it is the Hausdorff, or it's the definition.
All right.
Just yeah.
I think my time has come.
Yeah, I think I have to go as well, but yeah.
So clouds are fractals then.
I don't know. Not anything will form a fractal. I don't know.
What do you mean not anything?
Like not any like okay, for example, the Navier-Stokes does not form a fractal.
Why not?
They can't even fucking solve the thing.
Yeah, I think this is close to what
How is
I
it?
was saying, and like the Lyapunov exponent. Yeah.
I didn't keep the formula here, but
Again, this is 4.0.
Yeah, it's not gonna be good.
no, these are simple stuff. Oh shit, this is a new formula, right? And last time I
So what are the lambdas? Are they like eigenvalues or something? What are they?
last time I
Lyapunov exponents.
measured this.
I don't know exactly what that is.
Lyapunov dimension.
Orientation value for chaotic. Alright, the other time
What's the
I read
complexity
it.
of a fractal set? I don't know what a fractal set is.
I don't think this is the
Standard
same
fractal.
fractal that we're talking about. Like maybe it's.
No, what is a fractal set?
Anything that has, I think, dimension.
Okay,
non-integer.
set has a definition, right? Like
Set is a set of
yeah,
points.
yeah, yeah. So what is a fractal set?
It's
What's
said
the
that
conditions that
it's
makes
measure,
a
it's measure,
set? Uh-huh.
it's like the dimension of it is not the dimension of its space, right?
So what do you mean by dimension here? Exactly?
Like a curve in a 2D space has one dimensional.
Yes.
Right?
Yeah, yeah. So that you're talking about a manifold here. Basically, like if you have this,
But
this set
fractals
can
are
be
not
projected
manifold,
into
right?
yeah, yeah.
Manifolds are like continuous or
Yeah, yeah.
smooth. Or
So this
fractals are very non-smooth. So it is like you have this set, right? This is, for example, I
is,
don't know.
yeah.
Then you start covering it with these balls or cubes, and you say I have a covering for U is like a bunch of UIs, a countable covering of
Uh-huh.
them, and then you get these UIs to the power, the volume of these UIs. For example, they are balls or rectangles, and then you make them to the power of D.
And then this sum becomes finite.
Yeah, the smallest D that this sum becomes finite.
Okay,
or
okay, so minimize D such that this thing will be
Yeah.
finite, or
Yeah.
yeah.
That will be the dimension, Hausdorff dimension.
Right, I see. Okay.
But I don't know how is that related to
I don't know
this
what
one.
this Lyapunov
Yeah, well, I don't know
dimension
that.
formula is. Ordered Lyapunov exponents. Exponents of what?
I don't know this is. Oh, it
Yeah.
is how.
Yeah, so this I know. I think this is talking about the Lorentz equation
Yeah.
specifically.
Yeah.
So
I would like to thank whoever is going to watch this. Make sure that you like and subscribe and share it with your friends.
smash that.
Dude,
Smash
that
the
was
subscribe
amazing.
button.
No. What was your thing? You said once.
You know what you wanna do?
Smash that.
Smash that like button.
No, smash the hit button or something. Like you said something like this. That there was a
Smash the hit
gap.
button.
I remember. Smash the hit button or something.
Yeah.
Thanks for the invite and thanks for the charger as well.
All right. What are we doing next time, guys?
I think this is your show, so.
I don't know.
I-
I like that. Okay.
So
you
here's-
can-
You should ask
No.
Mesh to come.
Yeah, I
such
I think
a
Mesh has been like avoiding this. You know?
Yeah,
Should give him some shit.
Mesh and Optin.
No, Optin's been.
Yeah.
It's the
No,
famous
Mesh
one
also
where
came
like 20
once.
minutes
Mesh
of
came
no
once.
audio.
Yeah, I remember that.
Mesh came once too.
Well, no, that was like
No,
a
that
2
was-
minutes appearance.
Yes.
Bullshit.
No,
Bullshit.
force him.
But I like that. I really like that Lorentz equation that ended up. Wait a second. Oh, Lorentz was chaotic.
Yes,
Uh,
we went through the chaotic thing, and then
Mhm.
that's where we ended up. Yeah,
Because previously I had some talks with.
there's a
Jack.
course in McKee,
Mhm.
like chaotic systems. If
Mhm.
you want to take it, I never took it.
I mean, some of my lab mates work on these kind of things, like Lorentz systems.
No, that's chaotic
systems.
systems. Like that's just a whole course about chaotic systems.
No, they work on like control theory for chaotic systems.
Yeah. Anyways, I mean, you can take that course if you want.
No,
Yeah,
I
if
don't
you-
like take courses.
Like
anymore.
hit, no, sit in as a listener, like just to see
Hit
the
the
material.
registration
Why is
button.
Yeah,
Why is my head so big, guys?
because you're on the side of the lens and you're getting
Oh,
distorted.
it is the lens this side.
Yeah.
Alright, okay. I'm like.
No,
what
when you're on the
fuck is
sides
that?
of the image, it gets
Yeah.
distorted.
Ah, okay. Okay.
It's the lens effect.
It's a projection of my head through a chaotic
Yeah,
system.
like if I go here, my
Uh-huh.
hand will become big too. See.
Oh shit! Yeah.
Yeah.
All right.
So like if you want to appear big on a camera, like put your biceps like to the sides of the camera so it looks
all right,
big.
guys.
yeah, exactly.
Yeah, you
Okay.
know what you gotta do.
Yeah.
So that's why they don't show themselves in the camera.
Who?
Porn stars. They want to be always in the corner.
Yeah, so they always put the dick right at the bottom so it
Right,
gets
yeah.
distorted and it looks bigger.
That's true.
It is true,
Wow.
yes.
Lawrence, maybe Lawrence was a porn star. Who knows?
Nah, I'm pretty
I
sure
don't
it
know
was
what
a-
I don't know what the
By the
lens
way-
distortion has to do with Lawrence.
Wait
but
a
like, you
second.
know,
When we come, is it also like a
Okay.
it's a
spray?
jet. No, it's not a spray.
It's
Because
a
it doesn't.
jet.
It
I
doesn't
mean, if you put
aerosolize.
your thumb on it, maybe.
You can make it into a spray if you want.
or two guys like
Yeah,
spray?
yeah, that was
Yeah,
like
that
my
was
my
perfect.
my
Perfectly.
intrinsic like.
But yeah, you can make sprays in many ways. But yeah,
Aerosols, right? Aerosols.
aerosol.
Aerosol.
Yeah, aerosol. It could also be solid. It doesn't have to be liquid.
Aerosols. All right, guys. Thank you. Let me stop the shit. All right.